if you didn't get 23.74, you need to see why you didn't get 23.74. So what I did was I drew the actual thing. Here's the tower. Here's the two wires. And then I drew the two triangles separately. One triangle was 32 with 8 away. The other triangle was 56 with 8 away. And the question was to add the two together. Now, remember, when you do this, you're going to get a number on your calculator that's big and ugly, right? And you're allowed to round that. And then when you do this one, you're going to get a number on your calculator that's big and ugly, right? And you're probably going to round that, then you're going to add them together. If you want the best possible answer, of course, you will do this and then hit the plus button and then do this, then hit equals and round at the very, very end. Okay? Does everybody understand that? Everyone is good with number 16? Once, twice, thrice? Everybody who did it? All right. Computer's frozen. We'll take a moment while you all turn your books over to number 17, which is my good friend Peeping Tom. That is what the drawing had to look like. Tom is on the 13th floor of his building, 130 feet from the ground. So, of course, if this is 130 feet and Tom looks directly across, how far is this? Has to be 130 feet, right? He looks up at Elizabeth at 10, looks down at Sandra at 40. How many floors are between the two? Well, since you know this is 130, you can find this green side, right? I called that little a. So once I find little a, which is 130 divided by tan 40, I now have the adjacent to work out over here. Does everybody see what I have done there? Again, if you didn't do it, see what I did. This is being recorded so you can go back and look at it later. That arrow means I took that answer and I put it up there. Now, when I did it, did I actually do this and put a rounded answer up there, or did I leave it that way? What do you think? Did I do this on my calculator more than once? Or did I just put this up here as 130 over tan 40 and then did this math with that? That's what I did. Do you have to do it that way? No, by no means. And you get an answer. That will give you X, then you add it to 130. And if I'm not mistaken, it comes out to something like 155, I think, I can't remember, which is 16 floors, you could say. Or 15. I would accept either one because a floor is, 10 feet, but not exactly. I think it comes out to that. Did anybody do this and get something close to that so I can corroborate? Or do I have to actually get out my calculator? Toughest problem I have found in teaching this over the years is drawing the triangles, yes? The trig is not hard. Let's be honest, right? It's sine, cos, or tan. Drawing the triangles is the hard part, which is what makes this a good unit to show that just because you're good at math, or I lie, just because you're good at computation does not necessarily make you good at math, does it? And if you're good at English reading these questions and you can learn the 1 out of 3 that you're going to use, you could actually be good at math, right? That's kind of the point. You have to, it's not, I'm real good at reading, but I stink at math. Or I'm real good at math, but I don't read very well. It's not like that. That's not what the world's like. You got to be good a little bit at everything. And the computer's frozen, so we'll wait a moment till we get to 18. So we'll wait a moment till we get to 18. There's 18. So, the trick here was it was an isosceles triangle. What if you don't remember the properties of an isosceles triangle? What did you need to do? You needed to ask someone or look it up, right? An isosceles triangle means these two sides are the same, 8 and 8, and these two angles are the same. So since I wanted to find the angle of inclination, I needed that. Since I needed an angle, it was a shift situation. Shift of what? Well, I had adjacent and hypotenuse. Why is that 6 instead of 12? I had to cut the roof in half to make a 90-degree triangle. Am I allowed to do that move if the triangle looks like this? 6, 10, 14. If I cut that, is this 7 and 7? Why? Because that's not an isosceles triangle. Just because I draw a line there and make 90 degrees, I'm not cutting it in half. Does everyone understand that? That is a mistake all of you are going to make when I give you some assignments on this. You're going to cut triangles in half and you're going to say, or no, I lie. You're going to draw a vertical line and say you've cut it in half. It only works on isosceles and equilateral triangles. Okay? It only works if they are 8, if these two are the same, or if all three are the same. Everybody understand? Now, we could still do trig to find these sides, couldn't we? Right? If I knew any one of those angles. But don't assume that you're cutting it in half. Number 19 is another building question. I put it in on purpose because very often kids have trouble with 17. So I throw in 19 after I've explained it. If you didn't do 19, you should have less trouble with it after seeing how to do 17. I've used colors again to show you how it works. There's the green triangle, which I worked right here. This is the green triangle. And the purple triangle, which I worked right there. And then you'll notice I left it in long form and just did one shot of the calculator. Okay? Remember, this is not necessary. But if you notice you keep getting the wrong answer with your calculators, because you've got a backwards calculator or you screw up, divide, and whatever, if you write this out but get a weird answer, that still makes me happy because this is the trig. Does everybody understand that? I cannot stress this enough. Show me work. Because if you do, what if your calculator is accidentally in the wrong mode? You forgot to check it. But you've written this out, but you say this is 334 or whatever. If you've done this, I can say, okay, kid knows what they're doing. They're obviously just in the wrong mode or something. Understand what I am saying? The more you show me, you know what you're doing, the better I can, the more gracious I can be with your marks. Okay? And the two boys on the side of the mountain, there it is. They're on opposite sides of the mountain. So you had to find the two hypotenuses and then add them together. Again, I remind you, the hardest part is usually drawing the triangles. Which answer one? 18, I think it was 27. But the computer's frozen, so I can't go back there. Which is 18? Is that the... Oh, that's 41. All right. Everybody okay? All right. Now, in your books, you will notice I got 2 more pages right now. I don't need you to do all of them because I'm starting to believe you guys. But I'm going to recommend that we work on a few of them right now before we go to our thing that's going to cost cost you marks. All right. If you look on this page, you will notice. Oh man, you will notice that all the answers are there, right? I would recommend. I want you to do. Wake up. Wake up. I want you to do 13. I want you to do 9. And I want you to do 10. And you can do more, right? If you want more practice, but I want you to do at least those today. And I want you to do the building question on the next page, number 9. 13, 9, 10, 9, and 17 at least. And I want you to work on them now. Okay? You've got the answers. You have 4 grown-ups to help you. Right? I want to give you 20 minutes on that. And then we'll see where we are. Okay? Their answer to number 13, the statue question. Would anybody like to volunteer? Michael. 60.16 is absolutely right. You had the answers in the back. You could have put 60.2. Not in the back. You had the answers at the bottom. You could have put 60.2. You could have said 60 meters, 16 centimeters. You could have said approximately 60 meters. I don't care. Because what's the part I care about? That. Okay? Would anybody like to volunteer their answer to 9A? Because there was no answer on the bottom for 9A. You have to actually tell me what you got. Who has an answer for 9A? Because the answer 9 on the page is not right. Michael. 68 is abso-smurfly correct. Here is how you draw it. The helicopter left its base and flew. Where is it? Flies. Oh, I drew it flying east. Duh. The triangle should look like this. Base. It flies west, then north. 35 and 58. And then you want to know how far it is from the hospital home. So you do Pythagoras, and it was 68. Then it says, I want the angle between the path it took north, which is this, because it went north 58, and then to go back to the base, what would be the smart way to fly? The straight line. So I need this theta in here. Since I need a theta, shift tan or regular tan? Shift tan of opposite over adjacent, 35 over 58. What's the key to doing that question? You need to remember what? What do you need around this operation? Brackets. It's bracket 35 divided by 58. And what is the answer? 31 degrees. Because degrees we like to the nearest degree. Very soon in your math life, you will not be dealing with degrees anymore. You won't be worried about them. You'll be doing something totally different. You'll be using the R mode of your calculator, which is what engineers and physicists and all people that really work with angles use. Kind of like on Mythbusters when they show you how they do all the math and they do it in feet and inches on TV. That's for their idiot American audiences. The way they actually did the physics was in metric. And then they changed it to inches and stuff so their American audiences will get it. Also, in case anybody cares, the better of the two Mythbusters, Adam Savage, is about to do a live show in Vancouver with a new partner at the Queen Elizabeth Theatre. I cannot recommend it enough. If you're even slightly in the mood to go see A, somebody super funny, and B, somebody do some super cool real stuff, not David Blaine the magician, who's also coming to Vancouver, go see Adam Savage.
What myth are they busting?
I don't know, because it's not Mythbusters, because he's not with Jamie Hyneman. It's just Adam Savage and some other dude whose name I don't remember, because who cares? Right? Adam Savage and Matt Myers. Adam Savage? Oh, and some other guy. It doesn't matter. All right. And then number 10, the road rises 1 meter. There's the 1 for every 15 meters along the road. So if we are driving up the road, if I drive 15 meters up the road, I'm 1 meter higher up in the sky than I was when I started. So the question is, what's the angle of inclination? There's only one angle of inclination. It's that one. And since I need an angle, I must have to do shift. Shift what? What's that side? Opposite. What's that side? Hypotenuse. So it must be shift sine. Theta is opposite 1 over 15. What's theta? 3.82, so 4 degrees. Then, how far do I travel horizontally? That's the third side of a triangle. So what do I use? Could I do this with trig now that I have theta? Yeah. Or I'm going to use hypotenuse, or Pythagoras, I mean. Since I have the hypotenuse, it's the square root of 15 squared minus 1 squared, which is the square root of 224. 14.96. And I want the nearest tenth of a meter. So this is one of those situations where when we put it to the nearest tenth, what happened? We get the same number. Why? Why do we get the same number? Zara. Okay. Why do we get the same number? Why is that 15 and that 15?
Because rounding.
Because of rounding. This is really 14.966662955. If I only go 15 meters up the road, I've only gone up a tiny bit, right? But if I go 150 meters up the road, then this is going to be 10, and this is going to be, again, slightly less, because 4 degrees is so small.
And it has to round to the nearest 10th degree, which is the 9. And
Yep.
How you split that.
Now, on the next page, I asked for number 9. So let's look at number 9. The triangle is drawn there for you. Everything's there. I want the height of each tower. Well, that height right there is the height of this red tower, right?
So tower R, red.
Great, we'll call it R for red. Isn't that the same as this distance right here?
Yeah.
And then, don't I have this triangle? I know this is 35. If this is 50, what's this? 50. Now I have an angle and a side, don't I? So I can find this distance. What am I going to use? Theta is 35. My adjacent's 50. I need that. What is it?
Opposite.
Opposite is x. So then I just use my trig. A and O is tan. Tan 35 is opposite x over 50. So it is 50 tan 35. What's your answer? These answers at the bottom were correct. How tall is the red tower?
35. Wait, when you round.
When you round, it's 35 meters. Now, how tall is the blue tower? Well, if this is 35, blue tower, I need to add that, right? So, what do I have? I got 25 for a theta. I still got an adjacent of 50. My opposite is now y, right there. So I'm going to do the exact same thing, but it's going to be 50 tan 25 to get y. And then I add it to 35. 23, so 58 meters. And then the kite. In the kite below, the shorter diagonal is 6.8 centimeters long. I put this question on purpose because you have to think about this. It's tipped on its side. Where is the diagonal? It's there and there, because this kite could be rotated that way. Does everybody understand? I specifically chose to include this question because you had to think about how to orient the shape. Once you have that set, it becomes real easy, right? I'm going to need two colors, though. The shorter diagonal is 6.8. So this is 6.8, correct? When I cut it in half, what does this top half become? What's that? 3.4. Now once I have that, I can work out everything else, can't I? Because I want the 4 angles. So I can get that angle right there using opposite and hypotenuse. I can get that angle right there using opposite and hypotenuse. Then what do I do once I have that red angle? Because that's not the angle of the whole kite, is it? What do I have to do with that number to get the whole angle? What do I have to do with that? What did the green line do to the kite? Cut it in how many pieces? 2. So what do I have to do with that angle to find the whole thing? Times by 2. And what do I have to do with this blue angle to get this? What did the red line do? Split that angle in half. So what do I have to do with this blue angle? Times 2. So you have one triangle that you are working with. 7.8 and 3.4. That will get you both of these. And then you've got this triangle over here, which is 3.4 and 4.5 to get this angle here. That you multiply by 2. That you multiply by 2. And that you multiply by 2. This one's going to be sine and cos. This one's going to be sine and cos. No, it's not. Can I multiply this one by 2? Yes or no?
No.
Why?
Because they're 2 different angles.
Because this one's not cut in half, is it? This one is. So you got to find all 4 of those. Whew, that's a tricky question. Good thing I put it in there.
I thought you noticed that. I was kind of...
No.
Made it up something there?
You do notice it eventually when you talk about it. Right? That's why I keep saying show your work. Because I'm trying to think 3 steps ahead of what I'm actually writing, right? So do I need to go over that one properly? I feel bad now. That triangle, 3.4 and 7.8, because that one is cutting it in half. So this guy is times 2. And then this guy is, I just have to find him, blue theta. And then I've got this red triangle, which is 4.5 and 3.4. This guy is times 2. That is red theta. Then I got to add them. And then what do I know about this top one and this bottom one?
They're identical.
They're the same. So once I know, wake up, once I know red theta and blue theta, I know that's down here as well. Okay? So shift tan, shift sine, shift cos, or sine, cos, tan? Which one do you need? What do I need to find angles?
You need the shift.
I need the shift, because I have all the sides I need. Right? And then the answers are on the bottom. Yeah, no, it's not, because you can do Pythagoras. You can use any of them. You can use sine, cos, or tan. All right, listen please. You have 20 minutes left in class. This page, which is on your books, page 73, this is a review, which means it is 4 marks. It is due Monday. Just like the last review, I will be walking around Monday and finding out how much you did. There are 11 questions. If you have 5 of them done, the best you can get is slightly under 50%. Right? I'm going to give you a hint to this very first one because kids have a lot of trouble with it. What does this symbol mean? What does that mean? That it's 90-degree angle. Even though it doesn't look like a 90-degree angle. That is the corner of a room. Everybody understand? This is wall. This is wall. This is floor. So all these are 90s. But I only have 2 dimensions, so it's really hard to deal with. Everybody cool? Okay, that's the trick to that one. Turn the page over, please, in case you are at home working. Number 5, you need 2 triangles that are connected to each other, exactly like this question in your notes. Well, not exactly like, but similar to the question in your notes that required you to do 2 triangles that are attached, which was right here. It's kind of like that one. You had to use 1 triangle to find the other. So in that review, you want to look at the bottom of page 66. Not 66 degrees, bottom of page 66. This right here, if you don't understand that, it's no big deal. It's that thing we talked about on page... No, not there. On page... There, 56. It's headings on page 56. So for there, that is from headings on page 56. That's no problem. Number 8, You cannot see this line on your paper. It is photocopied badly. Everyone look at the screen. Curtis Point is right there. There's a black line that I can see quite plainly in mine, and it was visible on my computer screen, but when I printed it, it doesn't show up. This is Curtis Point. And this, bearings, you find out how to do these from bearings on page 56. And then the rest of it is normal. Everybody cool? When's this due? Monday. You got 20 minutes to work on it now, though. Might I suggest looking through the whole thing and doing the problems that you think are the most difficult now, while you have 4 grown-ups to help you. And also, I would like to remind you that I am the arbiter of where you sit. I'll put that in plain English for people. No worky, no togethery. Got it? Good. It almost does sound like it was directed at someone. Why would I ever be so hurtful as to direct it at someone? I didn't, because I didn't say any names. Did I, Kevin? Did I, Sukman? Did I, Jazz? Did I, Max? Did I, Zorro? No, I didn't. Go.